Welcome back. We're at day 2 of 12 days of generative AI, and today we're going to talk about autoencoders. And if you already know autoencoders fairly well, or think that you do, please give this a moment anyways, because I think there's going to be this little nuance that might be very valuable and interesting to you. And our gift to you today is a book chapter, one that I wrote several years ago, actually, when I was just starting to build up this whole notion of what do we need in order to understand that generative AI capability, the Donner passes of AI. And as I was writing that book, I got deeper into the Hopfield and Boltzmann machine neural networks and discovered something that I hadn't really known before, even though I've got a long, long experience in neural networks. Right after getting my PhD in chemistry, which was actually in statistical mechanics, which was the perfect, absolute best background to have for getting into AI. I wrote a book, and it was one of the very, very first books out on neural networks. And of course, I addressed Boltzmann machines. And in that time frame, I had also written a little tutorial, mostly for myself, on Boltzmann machines. And you know what? I still didn't get it. I really still didn't get it. But when I wrote that chapter, which was a few years ago, and the book is Statistical Mechanics, Neural Networks, and Artificial Intelligence. Not published yet because it's still in progress, but the key chapters that you really want to need, hey, we've got them for you. Links via the description box. That is, description box to blog post to all the links that I mentioned during the course of this. Very helpful for you. So here's the thing. In an auto-associative neural network, and we'll start with the Hopfield neural network. One long layer, so to speak, of neurons, everything connects to everything else except to itself. And we know that the Hopfield neural network, brilliant in its conception. I mean, there is a reason why Hopfield and Hinton got that Nobel Prize in physics, and it was that beautiful genius move of going from the Ising model in statistical mechanics to a neural network. Genius, absolutely fabulous. But what Hopfield didn't have was latent variables. It was just that every neuron connects to every other neuron, but not to itself. And then basically you minimize a free energy equation. Not illustrious in terms of performance. It couldn't memorize, it couldn't absorb that many patterns. So as an autoencoder, it was kind of weak. But it set the stage. Then Hinton comes in, and what he does is he introduces the latent variables. That, of course, is a regular, straightforward Boltzmann machine. Everything connects to everything, and the visible nodes, so-called, connect to the latent variable nodes, which are the hidden nodes, and to everything else. Then the restricted Boltzmann machine, which is what we use, that came along the next year. Visible nodes, or that pattern that we're attempting to learn, connect to the hidden nodes, but not to the other visibles. And the hidden nodes connect, of course, to the visibles, but not to the other hidden, dramatically simplified architecture. Now here's the important thing. With the restricted Boltzmann machine, RBM, let's call it RBM for short, you can rewrite that thing. If you draw out all the neurons and the connections, the ones that are allowed, you can then reorganize it so it looks like a multilayer perceptron. And so often we use a restricted Boltzmann machine for a classification task that we tend to think of input nodes and output nodes because we've got this multilayer perceptron mindset. But here's the thing. The algorithm does not recognize any difference between input nodes, the pattern that you're training on, and the output nodes, those that would identify a class. It treats the whole thing. It's still an auto-associative engine. So all those input nodes, so to speak, and the classifiers, because those are really part of the input training pattern, they're all on a par level with each other. There is no output node set where you can back propagate. What that means is this. When we take an RBM and use it for classification, which we often do, we do that far more often than any other kind of task. What we're really doing is we're mentally creating this little divide in the input variables in our training data, and we're saying, oh, we're going to set aside these small number of variables or nodes in the whole pattern to be our classes. What we're really saying is that The class identification is part of that whole auto-associative pattern, but they're not really class output nodes the way they are in a backprop. And that distinction, subtle though it may be, is so important, so powerful. So to assist you with this, Chapter 9 in that Statistical Mechanics Neural Networks AI book, we've got the link to that in the blog post. And then also, I wrote a blog post ages ago, and it's about when you treat an auto-associative engine as a classifier and when you treat a classifier as an auto-associative engine. You can do both. You can. But you just need to know what you're doing, and you need to know that underlying algorithm, and you need to know the equations, because equations dictate algorithm. They dictate actually architecture. And once you see the equations and the architecture, you know how it performs. And then once you know how it performs, you know what its limitations are. And now we're building some fundamentals. This is what gives us that deep, strong fundamentals layer on which we can build our other knowledge. So thank you for joining me. I may not have introduced myself earlier. I'm Aliana Marin, founder and chief scientist in Themysys Incorporated, founder of the Themysys Academy. And today we are bringing you day 2 of our Christmas present to you, which is the 12 days of generative AI. One little tiny blog post, one little tiny video for each day, hitting a topic in generative AI that will bolster your fundamental knowledge.
To ensure that you get access to each of these 12 days, please go to the Themysys website and opt in at https://themysys.com/Themysys, or just go to Themysys and hit the About button. They'll both get you there. Scroll down, do that opt-in form, and please, when you do the confirmation, make sure you move that email to your preferred inbox so you get all these future Themysys emails. Also, if you're really looking to build out your fundamentals in the generative AI space, please check out our course, Top 10 Terms in Statistical Mechanics, that gives you the essential vocabulary and background in a 3-week intensive yet gentle short course that will help you understand what you really need to know in order to master generative AI.
Thanks so much. It's great to have a moment with you. We'll see you again soon.